question or problem 6-25, and here we are moving away from annual compounding and taking a look at semi-annual compounding or semi-annual interest. So in this case, we have three different bonds with different par values, coupon rates, different years to maturity, and different required rates of return. So we're going to calculate the present value for each one, and we are going to do that using our present value function. And so for bond A, before we even input this, let's take a look at the different coupon rates and the required rates. And you'll notice for bond A, the coupon rate equals the required rate. And when that's the case, we know that the present value is going to be the same as the par value. So we know, without even calculating anything, that the value right now is going to be the par value. But let's take a look at how we would calculate that in Excel. So the rate is the required rate, 0.08. I'm going to put everything in annually first, and then we'll adjust it for semi-annual compounding. The number of periods is the number of years, showing is 11. The payment is going to be the par value of 500 times the coupon rate of 8%. I'm putting in parentheses just so that I can group it together before converting it to semi-annual interest. And the future value is just the par value, so 500. Okay, so we're showing a present value of $500 still with annual compounding. When we adjust it to semi-annual, it's going to be the same. So to adjust it to semi-annual compounding, we need to divide the rate by 2. So there's 2 periods in the year for semi-annual compounding. Number of periods, we're going to multiply times 2. So we've got 22 semi-annual periods over the course of 11 years. For payment, the $40 is an annual payment, so we need to convert that to a semi-annual payment by dividing by 2. It becomes $20. The future value stays the same at 500, and you can see as a result we still have a $500 present value for the bond. And if we look at bond B, a couple things to point out: the coupon rate is 11 and the required rate is 10, so this would be priced at a premium because the rate that it's paying is higher than what the investors are even expecting or requiring. So let's confirm that. We've got a par value again of $500, so that is reflected in our payment as well as our future value. We have a coupon interest rate of 11, so that is going to be changed here. Actually, I'm sorry, here 0.08 is a function of the payment. And years to maturity is 15, so the number of periods will change from 11 to 15. And our required rate is 10% for bond B. Okay. All right, so that gives us a present value that is, as we expected, a premium, so $538.43. Now we look at bond C. We have a coupon rate of 15 and a required rate of 13. So similar scenarios to bond B, where the coupon rate is higher than the required rate. So again, we're going to expect a premium here. Our par value here is $100. I'm going to adjust that in the payment box as well as the future value box. And our coupon rate is 15%, so we need to adjust that in the payment box. And our years of maturity is 5, so we change the number of periods from 15 to 5. And our required rate is 13, so let's change the rate to 13. All right. And as we expected, we have a premium, 107.19. And so remember, the par value in bond C was 100, not 500. So it's a premium because we're at 107.19 as a value. Okay, so that's a really quick and easy way to do these bond valuations in Excel with the functions. You could actually set this up a little bit differently with a table. You can use the icon here on the right of any of the table data tables in the problems and export it to Excel. Or most of the time, I just simply type it all out because it's usually not that much information, and I can just type it myself. So let me set it up here real quick. 500 and 100. And we've a coupon rate of 0.08, 0.11, and 0.15. Down here. This is our coupon. And years to maturity, we have 11, 15, and 5. And our required rate, 0.08, 0.10, and 0.13. Okay. So notice we can adjust decimal places with some of these quick keys. If we want to change things from numbers to dollars or whatever form, we can do that as well up here. So change it to numbers. I can back the decimals down to a whole number. So a lot of quick ways to adjust the formats of this. What I want to show you though is that we could do one of these questions here. So I could go back and calculate the present value with cell references. So the rate would be the required rate, again divided by 2, so divided by 2. The number of periods would be here, years times 2. And the payment is the coupon, I'm sorry, the par value times the coupon rate. I just like to group these together. And I'm going to divide that by 2 as well to adjust for semi-annual compounding. And then our future value is just our par value. So I'm just using cell references to identify the inputs where possible. I click done, so I have our present value of $500 as we calculated before. Now what I can do to save a little bit of time, maybe make sure that I don't have any input errors as I'm doing my other couple of calculations, I can just copy this formula down. So I'm going to hover my mouse over the lower right hand corner box, it changes to a plus sign, hold the mouse key down and just drag it down so that it will automatically calculate these for me. So as you can see, they match what we had over here that we calculated individually. So just another way that you can utilize Excel to save time and work problems much more quickly.